Hello, welcome. We discuss about the chapter solid state in plus 2. Now, we knew that there are 9 states of matter: solid, liquid, gas, plasma, Bose-Einstein condensate, fermionic condensate, quark-gluon plasma state, Rydberg molecule state, then Jahn-Teller metal state. But the important states are solid, liquid, gas and plasma. Here we discuss about the solid state. Here we study about the arrangement of particles in solid state, how they packed, and imperfections in solid. These are discussed in this chapter. Solid state is a state in which particles are arranged in a definite manner, or a well arranged manner. The general characteristics of solid state are they have definite mass, volume and shape. Also, intermolecular distances are shown in solid state. When the intermolecular distances are shown, the intermolecular forces are very large. Distances short, forces large. Then there are constant particles. Constant particles meant that atoms, molecules or ions. These are called constituent particles. Constant particles have definite position, fixed position, and can only oscillate about their mean position. Only oscillates in solid state. The constant particles only oscillates in their mean position. Oscillates. Only oscillates the mean position. Then fifth characteristic is they are incompressible and rigid. Solids are incompressible and rigid. These are the general characteristics of solid state. How the solids can be classified? Mainly into two: amorphous and crystalline. What are the difference between amorphous and crystalline state? We shall discuss about it. In amorphous state, the shape of the particles are irregular shape. Amorphous solids are irregular in shape. But in crystalline state, definite characteristic geometrical shape. Crystalline solids have definite characteristic geometrical shape. What are characteristics? They are all. That is, they are definite character, specific character. That is called characteristic. Specific. Definite characteristic geometrical shape. Second difference is for the melting point, at the melting point. Amorphous solids gradually soften over a range of temperature at a sharp melting point. But the crystalline solids have a sharp characteristic melting point. They melt at a sharp and characteristic temperature, definite temperature, at a particular temperature, specific temperature they melt. Third difference is cleavage. When they cut with a sharp edge to an amorphous solid, they cut into two pieces with irregular shapes, irregular surfaces, not regular in amorphous. But in crystalline, the cleavage is very regular. That is, when cut with a sharp edge tool, they split into two pieces and the newly generated surfaces are plain and smooth. Regular arrangement. That is crystalline solids have regular specific arrangement of particles. Heat of fusion. Amorphous solids do not have definite heat of fusion. Not definite. But heat of fusion of crystalline solids definite and characteristic heat of fusion. Definite and characteristic heat of fusion for crystalline solids. Then anisotropy. What is anisotropy and isotropy? Amorphous solids have isotropic character. What is isotropic? Iso sign. That is different arrangement of particles along different directions called anisotropy. But same arrangement of particles along different direction. At any different direction, they have same arrangement of particles. That is called anisotropy. Isotropy. Isotropic in nature. Amorphous solids are isotropic in nature. Same arrangement of particles. But anisotropy of crystals is due to different arrangement of particles in different directions. Along different directions. Anisotropy. All crystalline solids are anisotropic in nature. Then nature of arrangement of particles. Nature. What is nature? Amorphous solids are pseudo-solids or super-cooled liquids. They behave as super-cooled liquids. Liquids when super-cooled like that only consider the amorphous solids. That is pseudo-solids. PSCUDO. Pseudo means not correct. Assumed. Pseudo-solids. Not said to be pure solid. But all crystalline solids are true solids. Then we discuss in chemistry about solids. Solid means that true solids that are crystalline solids only. Anywhere in this chapter, solid means crystalline solids. Okay. Order in arrangement of constant particles. Only short range of order in amorphous solids. Order is short ranged. Only a short distance, short range. But in crystalline solids, long range of order. Order long range. For example, crystalline solid is sodium chloride. Salt, common salt. Crystalline arrangement. Then long range of order, the arrangement of constant particles are in order. Like in sodium chloride. But like in rubber, plastic, amorphous solids. Only order of arrangement of particles is short range of order. The main differences. Then crystalline solids can be further classified mainly into four. First one is molecular solids. There are three classification molecular solids: non-polar solids, polar solids, hydrogen bonded solids. The difference according to their bonding, chemical forces, attractive forces. In non-polar molecular solids, the constant particles are molecules, and here attractive forces are dispersion or London forces, which is studied in +1. Example: argon, carbon tetrachloride, hydrogen, etc. Iodine, carbon dioxide. These are all non-polar, not polar. What meant by polar? Polar means consider hydrogen chloride. Hydrogen has delta positive character, electropositive element. Chlorine is highly electronegative element, delta negative character. HCl. H is delta positive, Cl is delta negative. Hydrogen has positive polarity, chlorine has negative polarity. Due to this opposite polarity, the hydrogen is separate, chlorine is a separate one. Then that is dipolar. Two charges. Water is also a polar combo. H2O, HOH. H is delta positive, OH is delta negative. H is positive polarity, H has positive polarity, OH has negative polarity. It is dipolarity. You should study each word in definite meaning. Then the study is easy, we can understand everything. So many things. Then non-polar solids are soft insulator, very low melting point. They have very low melting point. Then second molecular solid is polar. Here also constituent particles are molecules, but the attractive force is dipole-dipole interactions. Like in HCl, SO2, these are polar molecular solids. They are soft insulator, low melting point. Third one is hydrogen bonded molecular solids. Hydrogen bonded molecular solids have also low melting point, insulator, hard, but hydrogen bonded molecular solids are very hard. Example, ice is a hydrogen bonded molecular solid. Here also constituent particles are molecules, but the attractive force is hydrogen bonding. Then the main differences are in bonding. Non-polar molecular solids have dispersion forces. Polar molecular solids have dipole-dipole interactions. Hydrogen bonded molecular solids have hydrogen bonding forces. Then second type of crystalline solids are ionic solids. Here, like the name, constant particles are ions. Here the attractive force is Coulombic or electrostatic force. Positive, negative attractive force. That is called electrostatic force. Examples are sodium chloride, magnesium oxide, zinc sulfide, calcium fluoride, CaF2, NaCl, MgO, ZnS, zinc sulfide, calcium fluoride. These all are ionic solids. Here the force is Coulombic or electrostatic force. Binding force is electrostatic force. They are hard but brittle. Hard but brittle. They can breakable but hard. They are insulators in solid state but conductors in molten state or in aqueous state. In ionic solids. They have high melting point. Ionic solids have high melting point. Sodium chloride, high melting point. Then third molecular solid, crystalline solids are metallic solids. Here the constant particles are positive ions in a sea of delocalized electrons. What are delocalized electrons? Localization means situated in a permanent position. Delocalized, D, which means removal of localization, delocalized. They are wandering here and there. Delocalized. The electrons are delocalized in a sea of delocalized electrons, positive ions situated. That is called metallic solids. In metallic solids, positive ions in a sea of delocalized electrons. That is, the electrons are wandering here and there. A sea of delocalized electrons. There, positive ions. These are the constant particles in metallic solids. Here the bonding is called metallic bonding. Metal attractive force called metallic bonding. Example, all metals, iron, copper, silver, magnesium, like. They are hard, but malleable and ductile. Malleable and ductile. They can be make into thin metal or sheet. It is malleable and ductile. They are conductors in solid state as well as in molten state. All metallic solids are conductors in solid state as well as in molten state. Fairly high melting point. Iron, copper has high melting point. All metallic solids have high melting point. Then fourth crystalline solid is covalent or network solids. These have very high melting point. A network, well arranged network solids. Here the constant particles are atoms, but the bonding is covalent bonding, strong bonding, covalent. They are giant molecules. like quartz, silicon dioxide, SiO2, a form of sand, another form of sand, SiO2. Quartz crystals, do you know, in watches quartz. Like quartz, SiO2 is a covalent or network solid. Another one is silicon carbide, SiC. Silicon carbide is known as carborundum. There is a factory at Kanjikode, carborundum factory, silicon carbide. Silicon carbide is known as carborundum. It is used as abrasive to polish the mosaic floors in olden days. They are called abrasive, polishing material or mosaic floors. Abrasive, silicon carbide, carborundum. Silicon carbide also covalent or network solid. Then another one is carbon, diamond. Diamond is a form of carbon. Only diamond is network solid. All carbons are known. Aluminum nitride, ALN, graphite. But diamond and graphite carbon forms are covalent solids. They are hard, but only graphite is soft. All covalent solids are insulators except graphite. Graphite is soft. Graphite is conductor. Graphite is only conductor in covalent solid. All covalent solids are insulators. That is the question. Which is the covalent solid is conductor? Graphite. Only graphite. Except like this. Very high melting point. Thus, there are 4 types of crystalline solids. Which are the molecular solids? They are further classified into non-polar, polar, hydrogen bonded. Second one is ionic solids. Third one is metallic solids. Fourth one is covalent or network solids. There is a table in your text. You study it. Thus, we finished the class today. And another day, I will come with the board, etc., with the mic arrangement for a complete version of the class, for getting complete version of the class. You should study these matters at first. There are 9 states of matter. One of them is solid. So the general properties of solids, which are the general properties, classification of solids into 2, crystalline and amorphous solids, the differences between crystalline and amorphous solids. Also there is one question there. Which is the amorphous solid used as best photovoltaic material? This is an important question. Amorphous silicon, which converts sunlight into electricity. Photovoltaic material, best photovoltaic material, amorphous solid, amorphous silicon, in solar panels. Then another matter discussed now, classification of crystalline solids. These are the matters we discussed today. There are so many questions there. Why are solids rigid? Solids have definite volume. Classify the amorphous and crystalline solids. Is glass against the supercooled liquids. Glass is amorphous, hence it is called supercooled liquids. That is the matter. Then there are so many classification of solids, like the properties of solids. You should study it well.